In 2008, India's Aeronautical Development Agency began developing a multi-role fighter to replace its large fleet of aging Jaguar, Mirage and MiG-23 fighters. The new project was tentatively dubbed the Medium Combat Aircraft, later revised to the Advanced AMCA, or AMCA, to be produced domestically by Hindustan Aeronautics Limited. Shortly afterwards, the Indian Air Force put in a serious addendum to the program. They wanted AMCA to be a stealth fighter, too. The AMCA is slated to use three-dimensional thrust vector engines, a design element found in the Russian FGFA and Su-35, which allow for supermaneuverability, superior pitch and yaw performance, especially at lower speeds. These engines are intended to generate enough thrust so that the AMCA can supercruise, that is, sustain flight above the speed of sound without resorting to fuel-gulping afterburners, and should be able to attain a maximum speed of Mach 2.5 with the burners engaged. The AMCA is intended to be made largely out of lightweight carbon fiber and titanium alloys to facilitate those high speeds, as well as a planned range of around 1,000 miles. The AMCA's internal weapons bay would conceal up to 4 munitions for stealth missions. At least 8 more weapons could be carried under the fuselage and wings for missions in which stealth is not a requirement. The weapons would likely comprise a mix of domestic, Russian, and Israeli missiles. Sensors would include a cutting-edge active electronically scanned array (AESA) radar, which offers greater stealth and superior resolution, as well as multiple infrared search and track sensors offering full-spectrum coverage around the airplane. The AMCA would also come with sophisticated data links to network its sensor data with friendly platforms, and a self-defense jammer of the sort found on Russian combat aircraft. The next step in the development process, however, may prove more challenging. India must develop the key components to fit the schematics drafted by the IADA. First of all, India must find a way to develop and manufacture radar-absorbent materials (RAM), as well as the precision manufacturing capabilities to create a stealthy hull. A protruding screw or poorly fit metal plate can cause a stealth aircraft's radar cross-section to blossom, so a high-fidelity manufacturing process is a must. India hopes to acquire radar-absorbent materials from France as part of a deal to purchase Rafale fighters have fallen through. Second, there is the requirement for a domestically produced AESA radar. Currently, India is using Israeli AESA radars in its Tejas fighter. However, the Indian Electronics and Radar Development Establishment has been working on a solid-state gallium nitride radar since 2012. Finally, the IADA and HAL will need to produce sufficiently powerful turbofan engines to meet performance specifications. This is further complicated by the need for an S-shaped air intake that will shield the reflective turbofan blades from showing up on radar, as well as specially designed nozzles to reduce the heat signature of the engines from infrared sensors. In theory, the AMCA will be powered by a domestically manufactured Kavri K9 or K10 engine, currently undergoing development by the Gas Turbine Research Establishment. But making powerful and reliable jet engines from scratch is hard. China has struggled to build a reliable domestic turbofan for its J-11B fighter, despite the considerable resources at Beijing's disposal. Only after the Kavri engines are ready, supposedly in 2019, can the serious work on the airframe really begin. Therefore, India is looking to foreign manufacturers to assist in developing the engine. New Delhi has received offers from General Electric, Rolls-Royce and Snecma, with GE's F414 turbofan, used on the U. Super Hornet fighter, seen as the most likely candidate. Indeed, there were extensive discussions concerning transferring F-414 technology to India entirely in 2016. And in February 2017 a tender was issued in which GE agreed to transfer 50% of the F-414 technology behind the F-414 along with a shipment of engines intended for use on the Tejas fighter. Russian thrust vectoring technology also seems likely to show up in the cavalry. Nonetheless, the transfer of engine technology is perceived to be a major sticking point in the AMCA program's advancement. Some observers are skeptical that the AMCA project will yield. On paper, the AMCA actually appears fairly promising, and real resources have been invested in its conception. However, to make it a reality, Indian engineers will need to work hard to develop the necessary radar, engine and RAM technologies to realize the design's promise.